It's time to start physics. We're going to do a little lesson on average speed today. Take things kind of nice and slow. Well, actually, it depends. We might not be taking things slow. It depends on how fast we're moving. Hi-oh! Okay, so average speed looks like this. The formula is V is equal to D over T. V is speed. You might be like, how come V is speed and speed starts with an S? Don't ask too many questions. That's how they come and get you. So speed is V, and for the most part, it's going to be measured in meters per second. D is distance, and distance is measured in meters. T is time, and it's measured in seconds. Meters is measured in meters. Distance is measured in meters, time is measured in seconds, and speed is measured in meters per second. So that's the formula. The formula being V is equal to D over T. Now, you'll find all of these formulas in your science data booklet. So this little crinkling sound I have is the science data booklet. And for the first little bit of physics, we're going to be using pretty much only a couple formulas, but this is on page 2. Now, you can rearrange this formula by timesing both sides by time, and you get TV is equal to D to solve for distance. This is known as the TV dinner formula. Okay, let's move on to the problem. Whoop, that was from the other day. What is the average speed of a clown that travels 150 kilometers in 2.5 hours? Okay, well, it's saying we can answer in kilometers per hour. Speed, remember, is distance over time. Distance is how far you go, 150 kilometers. What's that? Is that about from here to Edmonton? I think so. And time is about 2.5 hours. Okay. So when we put the two together, we go 150 kilometers over 2.5 hours. And when we divide that out, 150 divided by 2.5, we get 60 kilometers per hour. Now, I don't know why you're going so slow at 60 kilometers an hour. Maybe you are driving and there's a snowstorm or there's an accident, but that's how fast you're going. 60 kilometers per hour. Now, let's say we had to answer that in meters per second. There's a couple ways you can tackle that. Okay, the first off is you could solve it in kilometers per hour and then convert it to meters per second. So I'm going to do that. That's the first way. The second way is to go back to the original numbers and convert them to meters and to seconds and then divide them. So that's another way you could do it too. So let's do it the first way. So this builds on the lesson from yesterday. We have to eventually turn this into meters per second. So to get rid of hours, we put hours on top. How many seconds are there in an hour? 3,600. Thank you. 3,600 seconds. Okay, so the hours cancel. We got to put kilometers on the bottom. How many meters are there in a kilometer? 1,000 meters. So the kilometers cancel. So we're going 60 times 1,000 divided by 3,600. Okay, and that gives us kind of a weird number, but I'm going to round it to 16.7 meters per second. Now, the other way you could do is you could go back up to the original problem and say, oh, I could just convert 150 kilometers into meters by timesing it by 1,000. And look, that's kind of what we were doing to the kilometer function. 150 times 1,000, it's a really big number, 150,000 meters. And then what we're going to do is, how far did we go in time? What was our time? 2.5 hours. And we could times that by 3,600 because that's how many seconds there are in an hour. 2.5 times 3,600. And we get 9,000 seconds. Now, I guarantee you, when you divide this, you're going to get the same answer as which I've solved above. And lo and behold, you do. So there's a couple ways you can do it. If I'm being a nice guy, I might just let you solve it in kilometers per hour. If I'm being a jerkhole, it's going to be in meters per second. Okay, let's try another question. What is the average speed of a clown that travels 100 kilometers in an hour and 50 kilometers in the next 2 hours? Okay, so the clown went 100 and then it went another 50. So do we agree the total distance this clown has traveled is 150 kilometers? I hope so. Remember, clowns are merciless killing machines, and they will stop at nothing to just take you out. So 150 kilometers for a murderous clown, absolutely nothing in the big scheme of life. And we're going to divide this by the total time. The clown traveled for an hour, probably murdered some folks, went for another 2 hours, so our total is 3 hours. So when we divide this out, remember, because speed is distance divided by time. Now you can maybe do that in your head. We work out to being 50 kilometers per hour. So that clown is definitely traveling at about what the rate clowns should travel, which is faster than anything humanly possible. Because remember, they are merciless, murdering, killing machines. Okay, let's take a look at the next problem. Mr. Z is being chased by a clown going 14.5 meters per second for 10 minutes. How far did Mr. Z run? Okay, so this is a little bit trickier problem. Let's write down our formula. Now, what we're going to get into the habit in physics of doing is writing a little toolbox over here. Okay, we know how fast Mr. Z was running. 14.5 meters per second. We also know how long Mr. Z ran for, 10 minutes. Can we just quickly convert 10 minutes into seconds? Because there's 60 seconds in a minute. We can just times that by 10, and now we have 600 seconds. What we don't know is the distance that I've ran for. So what we have to do is rearrange for distance. Do you remember that formula from the other page? If we times both sides by time, we rearrange the formula and we get TV dinner. Time times speed is equal to distance. So we put the time in there, 600 seconds, and we times that by the speed, 14.5 meters per second. 600 times 14.5, and we get, ka-chow, 8,700 meters. Now, there's a thing in physics called significant digits where you have to round to the least accurate value. We're going to always try to do proper sig figs, but it's not a big deal in the Science 20 curriculum. For example, the least accurate value is 2, so I have to round this to 2 digits. So what you can do is divide this by 1,000 to get it into kilometers, and we get 8.7 kilometers. Now it's in proper sig figs. That's not necessary. If you didn't kind of get what I was talking about there, that's okay. The big thing is kind of understanding how I rearrange the formula for distance. Right? Rearranging formulas we do all the time, and we estimate, because that's how we tell people, how long it's going to take us to get somewhere or how far we've gone. You might be like, "Oh man, are we almost at our destination?" Well, how fast have we driven for? How long have we gone for? That's that formula right there. Okay, let's try one more problem. Okay, fleeing a chainsaw-wielding clown from hell, Mr. Z runs at 19.2 meters per second. He needs to make it to a safe house 1.2 kilometers away. How long does it take him to get there? All right, well, let's write down our formula, and let's start our toolbox. Mr. Z is running at 19.2 meters per second. He is very scared, so he is booking it. Okay, do we know how far? Yep. 1.2 kilometers. Can we just turn that quickly to meters by timesing it by 1,000? Let's do that. 1,200 meters. Hopefully everybody gets that. You times a kilometer by 1,000 to get it to meters. So what we don't know is time. So we have to rearrange this formula for time. Now there's a really cool trick that we're going to be using in physics where if you're solving for something on the bottom, what you can do is just switch it with the thing on the other side of the equal sign. So our rearranged problem looks like this. Do you see how the T and the V switched? Now you can only do that for things that are on the bottom of a fraction. but it's a really quick way to rearrange a formula. Time and v switch places. And guess what? Over in our toolbox, those are the things we know. We know the distance is 1,200 meters, and we know the speed is 19.2 meters per second. So when we divide that out, it tells us how much time it takes to run that distance. Okay, we get to 62.5 seconds. Your GPS does that all the time. All the time the GPS does that. It figures out how fast you're moving, how far you have to go, and it gives you an estimated time of arrival. Those of you that have started driving and use GPS, that's what it does. So a quick recap before I let you go. Here are the three formulas. I would maybe write these down because you're going to need them on the assignment. Speed is equal to distance over time. Rearranging for distance, we get TV dinner. Distance is equal to time times speed. And we can flip the bottom to solve for time. Time is equal to distance over speed because the time and the v can just switch. So those are our three formulas for the upcoming assignment. You can always reference this video. You can go back and say, oh, how did I do? What did he do to solve for distance? Oh, okay, that's it. What did he do to solve for time? Oh, because there's only three different types of problems I can throw at you. Problems that solve for how fast something is moving, problems that solve for how far you've went, and problems that solve for the time it takes to do that. That is the start of physics and the speed formula.